Okay, write linear equations from graphs. So you're saying, wait a second, we've already done this. This feels like a repeat. You're right. We have taken y equals mx plus b, which is called slope-intercept form. And what we basically have done is we've said, okay, if there's a line on a graph, right, if I can find that point, there's my b, which is my y-intercept, or where we begin. And then if I can find the slope, the rise over the run, I can find the slope. And that's great. But the reason why we're bringing this up again is because what happens if the y-intercept isn't perfect? What I mean by perfect is usually in all the problems we've done so far, we've had these nice lines where the line lines up perfectly on a y-intercept point. So like, oh, at 8, so I know my begin or my y-intercept is 8. Here, if we look at this, I'm saying, okay, well, this line crosses the y-axis, because we know this is the y-axis. I can guesstimate. I'm going to say 1, 2, looks like 2 2/3. 2 2/3. But I'm guessing, right? I don't know if that's true. That's just a guess. And if I'm wrong, then I've messed up. So I can use this to sort of say, okay, I think my y-intercept is going to be that. But I have to figure it out. And that's where point slope comes from. Because if I can find the slope, and if I can pick a point, then I can put it in a point slope form, and then I can find the equation of the line. So you're saying, huh? Well, let me explain what I'm saying. First things first, I always like to, and this is my way, this is my estimate, I don't know if I'm right or not. Might be 2, let's go 2, that looks like it's pretty high up there, so we'll go 2 3/4. How about that? And then I go over here and say, okay, I need 2 things to write something in point slope form, because remember, point slope form is y minus y1 equals m times x minus x1. I can't do slope-intercept form right now because I don't know what b is. So I go, okay, I do know this, I can find this stuff. I can find my slope. My slope is my rise over my run. Well, they've already given me a line. I say, well, my rise here is 1, and my run here is 1, 2, 3, 4. But remember, it's 4 to the left, the negative direction. And there's another way I can check this. I'm hoping that at this point you have on the top of your paper your positive, negative, no slope, 0. And I go, oh, positive, negative. Oh, this slope's got to be negative because it's going this direction. If you don't remember that going to the left is negative, then at least if you got 1 and 4, you can say, oh, but it's going to be at negatives. So my rise is 1, and my...
Hello, darkness, my old friend. I've come to tell.
And I come over here and I say my rise is 1, and my run is -4, and so my slope is -1/4. And people say, where do I put the negative? Well, you can put it anywhere. Most people put it out front, technically. Okay, and then I need to pick a point. And so people say, well, which point? There's a bunch of points. And you're right, there is a bunch of points. What I tend to do is look for the point that makes it easiest. The things that I look for instance, are that both numbers are positive, or that they're really small numbers. So the number I'm going to pick is 3, 2, because that's positive number, small, so if I have to do multiplication, it won't be a big deal. So I'm going to pick the point 3, 2, which means, which means if I'm picking my points, this is my x1, and this is my y1, and this is my slope. So now all I have to do is substitute those values back into what we've already talked about, which is point slope form. So I go, okay, y minus, and now I look at the problem, y1 is 2. And see, this is why I picked a positive number, so I don't have to worry about changing the sign. I could have picked any number. And then I say equals, and my m is -1/4. And then times x minus, and then I look at my x1, and it's 3. And there you have it. I have written an equation of a line in point slope form with what I had to work with. So that's why point slope form is so important, because I don't have a y-intercept that's clean. Now I can still put this in slope-intercept form. Let's see what happens. I'm going to go y minus 2 equals, and I'm going to distribute this -1/4 through, and I get -1/4 times x is -1/4 x, and -1/4 times -3 is positive, because a negative times a negative is a positive, 3/4. Okay, I'm not done yet though, am I? And so, okay, I go, okay, I got to get y alone, so I'm going to put a lollipop here. I want to get y alone. I get rid of the constant, so I'm going to go +2. And if I do it to one side, I do it to the other. And this is 0, and I get y equals -1/4 x plus 2 3/4. Well, crap, I guessed correctly. When I originally guessed, though, I said 2 2/3. That would have been wrong. My estimate was good, but that's okay. It confirms that what I was guessing is right. So the equation of this line in slope-intercept form is y equals -1/4 x plus 2 3/4, which is an ugly number, right? This is the reality that we've talked about in the past, which is math doesn't always have perfectly clean numbers. A lot of times problems are ugly. You just got to deal with it. So let's have you go ahead and try the next one. Go ahead and find the slope, pick a point, and put it in point slope form, and then put it in slope-intercept form. Okay, I'm assuming you did that. So again, my goals here are I want to get into, in the end, slope-intercept form, y equals mx plus b. That's my goal. But because I can already see that my y-intercept is off, right? I can see that it's already off, so I'm going to have to figure out something. So I'm going to be starting off with doing point slope form, which is y minus y1 equals slope times x minus x1. So y minus y1 equals m times x minus x1. And so I need two things for this. I'm going to need my slope, and I'm going to need a point. You get to pick the point. All right, and then I also like to do one last thing. I like to estimate. I don't know what I'm doing here. I'm putting SSS. I was going to go, I like to estimate. And so I'm going to estimate my y-intercept. I believe my y-intercept is, let's see, it goes 1, 2, 3. I'm going to go 3.5. Now I know that's not right, but what is useful for that is sometimes people make big mistakes in their equations and they end up with like -7. And you're like, how can -7 be my y-intercept when my line's up here? So making that estimate sort of helps me make sure I'm keeping on track here. So I think it should be about that. So I'm going to find my slope next. So I see that I have my rise is 1, 2, 3, and my run is 1, 2, 3, 4, 5. And I check positive, negative, no slope, 0. And I see that this slope is positive. So it's good. So my rise over my run will be 3/5, positive 3/5. And now I have to pick a point. So you can pick any point. Well, I'm going to pick this point, 1/4, or not 1/4, 1,4, because they're both positive numbers and they're small. You can pick any number, but I'm picking those. So I'm picking 1,4. And now, all I gotta do is substitute it into my point slope formula. So I just go down the line. I say y, underneath the y, minus, go up there and say, this is my x1 and this is my y1. So I'm gonna go minus 4 equals my m, which we figured out was 3/5. And then parentheses x minus my x1, which is 1. And again, because I didn't pick any negative numbers, I didn't have to worry about turning the sign positive or messing around with it. So here's point slope form. If I just need to find point slope form, I'm done. But if I need to put it in slope intercept form, now I have to simplify. Again, 3/5 times x is 3/5 x. 3/5 times -1 is -3/5. And then equals y minus 4. And then to solve, I need to get y alone. To get y alone, I'm going to subtract, or get rid of the -4, which is the constant. And if I add 4 to one side, to add 4 to the other side. This is 0, leaves me with y equals 3/5x. And then -3/5 plus 4 is, oops, I put equals because I'm thinking equals, but it's actually positive 3 2/5. And so I say, okay, that's slope, and again, it's not a pretty problem, but there it is. I know my slope is right, and I think my y-intercept is 3 2/5. I guessed it at 3.5. And 2/5, that's pretty close to half, right? Because half of 5 is about 2.5, so I guessed half. Well, guess what? That's pretty close. So my estimation was pretty accurate. This is the correct answer. Go ahead and try it. Okay, I'm assuming you did so. So again, I go straight to finding my slope, m, and my point. And remember, my point is my x1, y1, and I'm going to put that here. And so first, with my slope, I'm going to say, okay, my rise is 1, and my run is 1, 2, 3. But again, I went to the left here, and if I don't believe that, I go positive, negative, go slope 0, and look, this slope is negative, because that matches there, so this should be a negative 3, so this is going to be a negative 1/3 is my slope. And now I'm going to pick a point. There's multiple points I can pick. I have this nice clean point here. It's small. They're both positive. So I'm going to pick 2, 3. Now, before I begin though, I'm going to really quickly check. I'm going to estimate my y-intercept. I think my y-intercept is 1, 2, 3, and we'll just say 3 and a half. Now I know it looks like it's a little bit bigger than a half, but this keeps me remembering that if I get negative numbers, that'll be wrong. If I get a giant number, that's wrong too. Just kind of helps me out. Now I'm going to go into point slope form. Y minus y1 equals m times x minus x1. And the thing is, you just kind of gotta get that formula memorized because you just need it. All right, so y minus, then I go to my y1, which is 3, and I'll substitute that in, equals m, which I now know is negative 1/3, parentheses, x minus, then I always write down the negative sign and then look at the point. And my x1 is 2. I'm good there, right? So that's point slope form. If I just said find point slope form, this is the equation of the line. It's written in point slope form. But if you wanted to put it in slope intercept form, because a lot of people like that, that means we're simplifying. Negative 1/3 times x is negative 1/3 x. Negative 1/3 times negative 2 is positive 2/3. And y minus 3. And now I want to get y alone to put it in slope intercept form. So I'm going to go plus 3, get rid of the constant. I'm going to add 3 here because constants always like terms. 0, and here go y equals negative 1/3 x, and 2/3 plus 3 is plus 3 and 2/3. And so we said 3.5. 2/3 is like 0.6. It's above a half, and I already said it looks like it was more than a half, but it was a good way to estimate. So guess what? There's my answer. And again, so do you find that these problems happen a lot because a lot of times we don't have perfect y-intercepts, and so we have to get good at doing these problems. All right, that's it. Hope you can do it. Good luck. Go ahead and take care of the problems below.